Hey, good morning or good afternoon or good evening. I'm Chuck Young. I'm the business development manager with Tricor Metals. I'm also the company metallurgist. Going to talk a little bit today about a task group that NACE has formed, TG 575, to develop a white paper on corrosion prevention and control for marine scrubbers. It's something that was put together in early 2019, and a bunch of volunteers have started to write portions of this paper. Briefly, just to go over the market size, Tim Mornian is going to talk a little bit about the titanium in this market, but this is from the Exhaust Gas Cleaning Association. And this is from 2018, so it's a little out of date, but it shows that even in 2018, there were 983 ships that had scrubbers installed or on order. And as of January 1st of this year, all ships are supposed to have scrubbers or be using low sulfur fuel if they're in a sea environmental control area, which means around the boundaries of all of the continents, as well as in some of the major shipping lanes, like the Caribbean Sea and the Mediterranean Sea. Want to talk a little bit about the task group composition, and this will show you something here that NACE is a very much not run, I would guess, but very much a stainless and nickel organization. Very few others are involved in that. But this task group, which is volunteers, contains 10 people from the stainless and nickel industry. Some of those, in fact, a lot of those are gentlemen who have been in the industry 30, 40 years, and some of them are now just consultants. Non-metallics industry has 6 people from there. There's 2 from the naval organizations and 2 NACE reps that are overseeing the writing and how it's all put together. And then there are 2 of us from the titanium industry, myself and Rob Henson from VSMPO, and we're involved in looking over all of the chapters as well as writing the chapter on titanium. Back in early 2019, when the task group was first formed, Bud Ross, who was the chairman, he used to be with Inco and now he's a consultant, put together a survey, an internet survey of ship owners, operators, and shipyards. And he got back 6 responses out of about 100 surveys that were sent out. So it's typical of a survey. You don't get many responses unless you really follow up on it. Services for the scrubbers were fairly new, just installed, and up to 10 years of service. And if you look on the right side of this slide, you'll see where a scrubber is actually installed. It's installed right near the stack or in the stack. And most of the time that's right over the engine room. So if there's any problems with the scrubber, any leaks out of the scrubber system, it's probably going to go down to the engine room and cause major problems. Conditions in a scrubber are vary depending on where you are in the scrubber. You have gases coming off of the combustion of the engine that are 300 to 450 C and very dry. And they come into the bottom of the scrubber, and they are then counterflowed with seawater or with seawater plus some kind of chemical like sodium hydroxide or magnesium hydroxide. Temperature in the scrubber goes down, and but there is a wet-dry interface at the bottom of the scrubber where sometimes you have dry, sometimes you have wet, and that would be the major concern for corrosion in the scrubber. Outlet temperature is normally 20 to 40 degrees C, and it's a wet, but you still have scrubber pHs of 2 to 4. And because of the sulfur content in the fuel, this is going to be some sulfuric acid. The chloride content is going to be high because you're using seawater. Plus there's probably some chlorine in the fuel itself, so that you get 20,000, 30,000 chloride levels. Materials of construction used, and these are from the survey. These results are from the survey, so that these are the initial scrubbers that were put in over the last, say, 10 years. And one thing to point out here is that these are all nickel or stainless alloys. It shows that the nickel and stainless industry is very well known in these types of markets, and it also shows that they try to use the lowest and least expensive nickel alloy first, and then they go up into higher alloys, just like they did back in the flue gas desulfurization market for coal-fired power plants back in the 80s and 90s and early 2000s. But anyhow, the venturi and the inlet duct, and this includes may include where the wet-dry zone is, or the absorber bottom might be the wet-dry zone. But they're using a 2205 duplex stainless steel or a 2507 duplex stainless steel. Some 6 or 7% moly like AL6XN or 254 SMO. Some alloy 59, which is almost equivalent to like 625, and then C276. And one thing to point out here is that most of these materials of construction have been determined either in Europe or Asia. Very little of this is done in the United States. So that's why the alloy 59 is very prevalent here. The top of the absorber tower is normally 2205 or the 6 to 7% moly. The upper part of the tower going into the stack has to be an alloy, but it does not have to have too much corrosion resistance because the temperature is lower, and you probably don't have too much sulfur going up there, so the pH is probably not critical. The other part of the scrubber, and we'll get into that in a second, can be other materials. This is survey results. One of the things that I asked Bud Ross to put into the survey, because I knew that no titanium had been used in this market, is why didn't the shipbuilders, the ship owners, the shipyards, and especially the scrubber manufacturers or scrubber design firms look at titanium? And we see the typical answers to a question of why don't you use titanium? It's cost. They say it's too high cost. They say it's not available. They don't have any experience with it. One gentleman said, he said that they have no experience and they don't know how to weld it in the shipyard, and they don't know if they can get welders that can weld titanium. And lastly was sulfuric acid corrosion. And these are typical responses when the nickel alloy and stainless alloy people have been talking. These are their talking points about why not titanium. So they have shown the industry that titanium may not be good, and these are the reasons why. So this is something we have to correct. In looking at the survey, there were a couple of failures reported. 2205 duplex stainless steel weld corrosion after just a little over 1 year, and a little over 2 years service, some 254 SMO, that's the 6 moly, crevice and weld corrosion. Now, the key here is 2205 has to be welded correctly. Otherwise, you get a change in the ferrite to austenite ratio and in the weld or in the heat affected zone, and that could cause it to suffer corrosion fairly fast. So that's probably what happened here is the welding wasn't done correctly. 254 SMO crevice corrosion would be expected if you had under deposits in the scrubber, as well as weld corrosion because of welding problems. And again, that just shows this is a Wartzaler out of Poland there, where their scrubber goes and what it looks like. The white paper, just to give you an outline, it's going to first start with a description of an open loop scrubber, a closed loop scrubber, and a hybrid scrubber. And I'm not going to get into too much detail on all of this. Just to know that open loop, the seawater goes through once and then goes out to the sea. Closed loop, it just keeps recycling until it has to be eventually put out to the sea after some treatment. A hybrid scrubber can do both. On all of these scrubbers, you do have to worry about when they are bypassed, because there may be sometimes when a scrubber isn't operating. So you have the 300 to 450 C off gases from the diesel engines going right through the scrubber and up the stack. Environments, of course, you have seawater, and you can have some alkalinity depending on if you use whatever chemical you use to put into seawater to help try to control the pH. There is going to be a chapter on that. Materials of construction, there are basically four chapters: stainless steel, nickel alloys, titanium, and non-metallics. And as I said before, Rob Henson and I are working on, or have worked on the titanium, and we are making comments on all of the other chapters as well. After that, they're going to talk about pitfalls in welding, construction, and inspection. This is one chapter where we're going to hopefully get some good input into it, because we don't want people with the misconceptions you can't weld titanium, even in the field. Also, in addition, and I think I talk about it in a little bit, is they worry about fluorides, and we need to show that fluorides in this environment aren't going to be a problem. And then they also talk about, there's a chapter on service performance and history, which is going to probably be very minimal because we really don't have anything other than a couple of anecdotal comments from the 6 people that sent in the survey. And then the last chapter is going to be best available technology for MOX. And that is going to be an interesting discussion once we get to that, because how do you determine what the best available technology? The nickel people think they know. The stainless people think that 2205, 2507 is great. And of course, we think that probably titanium should be used in some areas. So we're going to have an interesting discussion when we get to that. Basically, just to show you, here's the schematic of the scrubber components. The scrubber is basically that big vessel in the top, and it has some injectors in there to put the seawater in the top. It also may have a demisting pad in the top. The scrub gas goes, or the exhaust gas goes in the bottom. That's where the wet-dry interface is, and then goes out the top to the rest of the stack and then out into open air. The cooler there is using seawater to cool some of the water, recycled water, makeup water before it goes in. Those are normally plate and frame exchangers, and there's where titanium is used, either titanium or they're also using 2205 and plate exchangers there. The rest of that system, the process tank, the chemical addition tank, the wastewater treatment, holding tank, all of that is basically ambient temperature. It's seawater plus whatever other chemicals in there. And a lot of that is going to be non-metallics, or it could be even just 316 stainless steel. If they wanted to really go up, they could probably use 2205. Uh, current sections, just to show you, these are the current sections on materials that have been done and have been reviewed. And just to show you, stainless steel is 8 pages. Nickel alloys, they talk. I mean, there's a lot of stainless steel and a lot of nickel alloys, and they talk. So they're talking about a lot of those. We have 4 pages with 14 references. Those references are for seawater corrosion, as well as for the flue gas desulfurization work that was done back in the 80s and 90s and early 2000s by a couple of the titanium industry suppliers as well as fabricators. And then the non-metallics. And I'm sure there's going to be references added to the nickel alloys and the non-metallic section drafts. But as I said before, everyone in the on the committee is going to be able to review all of these. We have reviewed basically the nickel alloys and for a little bit the stainless steel. We're on the 3rd draft of nickel alloys, I think. We're on the 2nd draft of the titanium, gotten some comments back, and we've responded to those. So it's still a ways out. Other sections, as I said before, the description is basically a generic description of the system. It doesn't go into materials. It doesn't go into what the corrosives are. It just describes the system. It should be fairly straightforward, and I think it is. Environments talks a little bit about the pH, about the chloride levels, about they even get into some of the fluoride levels and that kind of stuff, and the temperature, and look at what corrosion could be expected there. And then looking at the pitfalls in the design of these systems. We just received the initial draft on that. We're going to be reviewing that. That's going to need a lot of work, I think, just looking at it. So it's going to take a while to get that done. Service performance, there's really no draft yet on that, other than a very, very minimal 2-page that basically describes the 6 answers we got, which say that this scrubber was used for 10 years, this scrubber was used for 3 years. That needs a lot of work. And then, as I said before, there's no draft yet on the best available technology, and that's going to be a battle to make sure that titanium is included in there. And Rob and I will see how we can do on that. The titanium section, just to show you what we've done on that. Titanium section, we've talked about grades 2, 2H, 7, 7H, 9, 12, and 16, 16H. And try to emphasize there is inventory available all over the world in all forms. Plate, sheet, piping, forgings, whatever, to make sure that the industry understands it's not a question, you can't get titanium. And then also put in there the cost of titanium versus the nickel alloys, using the information I developed a number of years ago, looking at normalized cost of titanium versus the nickel alloys. And actually, no one in the nickel industry has disputed that yet, so that's good. Also, we talk about corrosion in the FGD systems in the coal-fired power plants, which I'm very familiar with from my work in the 80s, and also then seawater corrosion. And the 2 things we have to do here, as I mentioned before, is we have to negate the fluoride and the sulfuric acid negatives. And we have a good example in one of the FGD systems in the R.D. Morrow plant of South Mississippi Electric Power back in the 80s. They had a bunch of fluorides in there, and they did not affect the titanium at all. The titanium worked perfectly in that system. So we have that in there to negate any questions that the nickel people might raise there. And then we look at weight savings, because if you remember where these are up near the top of the ship, right underneath the stack, or actually in the stack. So they're above the water line, and any weight save, and this is adding additional weight to the ship, so that you need more ballast, so you can carry less cargo. If you save weight with titanium, that means you can increase your cargo load or don't need the ballast. So that that's a definite advantage for titanium there. And then looking at savings related to initial cost and operating costs. If you have to replace these every 7 to 10 years, that's going to be a major undertaking by the ship owners. If you have to repair them regularly because of weld corrosion or because of under deposit corrosion, it's also going to be a cost. And then also, what happens if you start getting a leak at sea and you have to shut down your scrubber? First of all, you may be out of compliance then. And second of all, if you remember that the scrubbers were high up in the ship over the engine room. And in fact, there was a problem on a ship in the Far East where they show that the scrubber had a weld failure or a corrosion failure, and there was looked like a flood of water going into the engine room, over the engine, over all the electrical panels and everything. So that if you do have that kind of problem while you're under operation, you could have a major situation on your hand and maybe even lose propulsion power. And then we also talk about welding parameters to ensure that people understand you can weld titanium. You can definitely weld it in the shop very easily. These scrubbers could be put together in the shop, and it can be welded in the field. So trying to negate any of the issues that can be brought up by the nickel or stainless people. But where do we go from here? Tricor Metals is based in the U.S. We do a little bit of shipping to outside of the U.S. To Europe and the rest of the world. However, most of these markets are in Europe or in Asia. That's where the shipyards are. There's only one scrubber design firm in the U.S. right now. They're in New Jersey. All the other scrubber designers, even the ones who are getting some of their scrubbers built in the U.S., are in Europe or in Asia. So we really need to get into those areas and to get into those scrubber design firms so that they put the titanium as a proposed material of construction or as an alternative material of construction. This is both for new ships plus for maintenance, because the shipyards they're going to be maintained at are probably in the Far East, in Asia, or in Europe. So, this needs to be a global thing, not just NACE in the U.S. or the U.S. manufacturers or the U.S. fabricators. We need the titanium industry as a whole, especially in Europe and Asia, to focus on this market. And again, like I said, there's a lack of awareness in the marine industry of the fact that titanium can be used in this market. Little or no titanium technical marketing. I mean, we have marketing about seawater, but we don't have marketing about seawater with sulfuric acid in this market. And just having seawater corrosion resistance does not mean this is going to work. As I've said a couple times, the nickel stainless steel marketing people, they stress the titanium negatives. When they go in and talk about their material, they're pushing their material, but they're also saying negatives about all the other materials, including titanium. So we need to really look at that. And finally, participation in this task group may help. That's why I got involved. That's why Rob got involved, to make sure that titanium gets its fair shake in a NACE publication. So, and I hope this is successful. But as I said before, we need titanium technical marketing throughout the world for this market. And I just want to thank you for listening to me. I'm Chuck Young, Tricor Metals. You can get in contact me either by email or by phone, and I'd be happy to take any questions during the question session. Thanks a lot.